on here? We're going to do number 5. So here I have a 2 minus sign, and that's equal to 2 minus cosine. I don't have a Pythagorean identity there, and honestly, I can't make sine equal cosine at any point in time. So now I just need to kind of go, what is this saying? As with any of these other problems, it's asking me when does the left side equal the right side. So here I'm wanting to know when does 2 minus sine equal 2 minus cosine. So let's make this a little bit more clear for some of us who kind of don't necessarily see what it's saying. So if I go ahead and subtract 2 from both sides, let's go ahead and just kind of get rid of that. Well, it cancels out on both sides, doesn't it? So now I have negative sine is equal to negative cosine. All right, and then I can go ahead and let's just get rid of the negative in front of the sign. So that means I divide both sides by a -1, right? And so it's going to cancel out there. It's also going to cancel out here. So what this is asking me is, when does sine equal cosine? Well, think about it. When you're going around your unit circle, the only time that your sine values and your cosine values are exactly the same are at pi over 4 in your first quadrant and at its sister value that you're going to have in the third quadrant, which would be 5 pi over 4. So that's what I've got. I've got x is equal to pi over 4 and 5 pi over 4. And that's where they are both equal to positive square root 2 over 2, or both are negative square root 2 over 2. All right, let's look at this. Here we go with our multiple choice questions here. These are our AP style multiple choice questions from AP Classroom. So this says the function f is given by f of x is equal to sine squared plus cosine plus 1. The solutions to which of the following equations are also the solutions for f of x is equal to 0. So what this is saying is I need to go ahead and solve this equation right here, set it equal to 0, and see which one of these down here is going to match. And as I'm going through here, it could potentially just appear in terms of A, B, C, or D could be what I have written when I changed my equations around. So this very first thing that I'm going to do is if I look at everything that I've already done in my problems, I'm going to go ahead and I'm going to be taking this equation and changing this to be 1 minus cosine squared, because that's my Pythagorean identity. So let's go ahead and do that. So I'm set this equal to 0, and I'm going to change that sine squared into 1 minus cosine squared. And then I've got plus cosine x plus 1, because that's coming from the problem over here. Okay? And so now I need to go ahead and just rearrange this and solve. So I'm going to have 0 is equal to negative cosine squared x plus cosine x. And then I have 1 plus 1, so that's plus 2. I need to scroll over a little bit here. So it's plus 2. Does that equal anything that I have over here? Well, this has a cosine squared, not a negative cosine squared. This one has a positive cosine squared. This has a positive cosine squared. Mine's negative. Well, what if I go ahead and instead of having everything over here, I could go ahead and bring everything over to the other side? Wouldn't that just make it be positive cosine squared minus cosine minus 2 is equal to 0? That's just bringing everything over to the other side instead. Well, shoot, that's right here, isn't it? So that's going to be what I've got right here. This equation right here is going to have all of the exact same solutions for the sine squared plus cosine plus 1, okay? All right, let's look here. Number 7, the function g is defined by g of x is equal to secant squared plus tangent. What are all solutions to g of x is equal to 1 on the interval from 0 to 2 pi? Okay, so instead of setting this equal to 0, it's telling me to set it equal to 1. So I have 1 is equal to secant squared x plus tangent squared x. Okay, so now in order to solve this, I'm going to end up having to change this secant squared, and I'm going to have to use my Pythagorean identities. We know that secant squared is going to be equal to 1 plus tangent squared. And then I got plus tangent x, because that's just coming from right here. Okay, so let's go ahead and rearrange this. I'm going to go ahead and bring this 1 over here. And so now what I've got is tangent squared x plus tangent x is equal to 0 because the 1 canceled out, 1 minus 1. Okay? Now, don't fall for the trick. The trick here is for you to say, oh, well, let me just bring this tangent over here and just divide by tangent. If you do that, you're eliminating an entire option for an answer here. By that, I mean right here, I have a GCF, okay? They both have tangent here. So if I bring out a tangent x as a GCF, I'm going to have a tangent x on the outside, and on the inside, I'm going to be left with a tangent x plus 1 is equal to 0, okay? Now you see how that's different. What I mean is if I had instead, and this is doing it the wrong way, but this is what a lot of people want to do and why it's wrong. A lot of people want to go ahead and bring that tangent x over to the other side, minus tangent x, and then just go, oh, well, then I can just go ahead and divide both sides by tangent x. And now here, if I do that, that's going to cancel one of these out. And now I'm going to have tangent x is equal to negative 1. Well, I get tangent x is equal to negative 1 here in the bottom when I set that up equal to 0 and solve. But I didn't get this one on the outside, did I? I don't have that tangent x is equal to 0. That's important. So you can't just like take it and bring it over to the other side and divide it out. You can't do that. Because really, I've got tangent x is equal to 0, and I have tangent x plus 1 is equal to 0. And so here, I'm going to get tangent x is equal to that negative 1. So these two match, but again, I didn't have this tangent x is equal to 0. So now what I'm solving for is when is x going to get me my tangent inverse is equal to 0? And when is my tangent inverse going to be equal to negative 1? Well, tangent is equal to 0. That's going to be when I get 0 over 1 for my sine over cosine. So sine is equal to 0, cosine is equal to 1, or sine is equal to 0, and cosine is equal to negative 1. Where does that happen? That happens at 0 and pi. So I'm going to have x is equal to 0. I've also got pi. And then my next part here is when is tangent equal to negative 1? Well, again, that's going to be on all of my pi over 4s, get me 1s and negative 1s, but the negative 1 is going to happen at 3 pi over 4, and also, again, at 7 pi over 4. So I've got all of my solutions here. If I had done it the other way, I would have only gotten the 0 and pi. I would not have gotten 3 pi over 4 and 7 pi over 4. What I'm going to show you, I'm going to just prove it to you really quick here. If, you know, I know if you guys don't necessarily believe me. So in this particular case, what I'm going to do is I'm going to take the equation that I was given here, this 1 equals secant squared plus tangent, and I'm going to plug it in. So I have 1 equals secant squared x plus tangent x, okay? And what I'm going to do here is I'm going to go ahead and plug in this 3 pi over 4 for x. So I have secant 3 pi over 4, and this whole thing is squared, plus tangent 3 pi over 4. Well, secant at 3 pi over 4, that's the reciprocal of my cosine. So that's going to get me 1 is equal to, cosine at 3 pi over 4 is negative root 2 over 2. So I'm going to have negative 2 over root 2. And then we're going to go ahead and square that. And then I got my tangent at 3 pi over 4. Well, that's going to be the square root 2 over 2 divided by negative root 2 over 2. So I get negative 1. Okay. Now, if I take this number that I have right here, this negative 2 over root 2, and I square that, that's going to get me that negative 2 squared is going to become 4. And then root 2 squared becomes 2, minus 1. Okay? And what is 4 divided by 2? Well, that's 2. If I take 2 minus 1, does that equal 1? Yep, it sure does. So if I had done it the other way, I would have completely eliminated that 3 pi over 4 and that 7 pi over 4 as answers. And as you can see right here, they are in fact answers. So do not leave those out. Now, if I come up here and look at my multiple choice answers, well, this is wanting me to know between 0 and 2 pi, it's including 0, it's including 2 pi. So let's come back down here. I didn't include 2 pi down here because all of my other ones had been from 0 to 2 pi, not including it. But if it includes 0, it's also going to include 2 pi. So I have 0 pi, 3 pi over 4, 7 pi over 4, and 2 pi. So let's see, I've got 0 pi, 2 pi, 3 pi over 4, 7 pi over 4. Well, there's my answer right there. Okay. I don't want to look at these or these right here because, well, this is giving me an infinite value set right here. I have where k is any integer. I don't have any limitations on k. I can't go outside of my domain of 0 to 2 pi. So those two I can't use. And this one, that's saying pi over 4, pi over 2, 5 pi over 4, 3 pi over 2. Well, literally none of those work. None of those are what I need. That pi over 4 would be if it was positive 1 and not negative 1. The 5 pi over 4 was the same thing. That would be for positive 1, not negative 1. Pi over 2 would be when my sign actually is going to equal 1, and my cosine is going to equal 0. Likewise, 3 pi over 2 would be when my sine is equal to negative 1 and my cosine is equal to 0. So those would get me my cotangents would be equal to negative 1, not to, or I'm sorry, cotangents would be equal to 0, not negative 1. So B is definitely not it. So my answer here is A. Okay. Hopefully this makes more sense seeing it the second time around.